Hello, and welcome to the webcast. My name is Mark Greenberg, and I am a sales engineer here at Pentec, and I will be talking to you today about Pentec System Flow software. So what is Pentec System Flow software? System Flow is a software application designed by Pentec that is used to control a Pentec Talon high-speed recording system. As you can see, Pentec's Talon high-speed recording systems consist of three different recording system product lines: RTS commercial recording systems, RTR rugged recording systems, and RTX extreme recording systems. And the same System Flow software application is utilized across all of Pentec's Talon recording system product lines, which provides all Talon recording systems with both a consistent look and feel, as well as providing all Talon recording system users with an easy-to-use and easy-to-integrate user experience. System Flow provides a set of function libraries and tools that are used for recording system control. More specifically, System Flow consists of an application programming interface function library, a graphical user interface, and an integrated signal viewer. System Flow is based on a flexible client-server architecture which enables server control from either a local or a remote client software application, and it allows both the client and server software applications to run on different operating systems, which essentially makes a Talon recording system platform independent. In addition, System Flow utilizes an NTFS file management system, which allows a user to work with recorded files immediately after a recording session is completed. It also provides instantaneous support for all Windows signal analysis and processing tools, like MATLAB and many others. And by giving the user the ability to work with recorded data immediately after capture, using an NTFS file management system eliminates time-consuming data conversion processes that are required when using software that utilizes a proprietary file management system. On this slide, you see a list of all the API functions that are included within the System Flow API function library. You will notice that there are only a total of 17 API functions included within the System Flow API function library. That is not very many at all, which is a big benefit to a software programmer that is tasked with having to integrate a recording system into their own software application. A streamlined software API function library leads to a shorter learning curve for a software programmer, which in turn translates into a recording system that is both easy to integrate and less costly to integrate. And that is a major advantage for both software programmers who are responsible for integrating hardware into an already existing application and for program managers who are responsible for keeping program costs to a minimum. But for those customers who are looking for a ready-to-use, right-out-of-the-box experience, we have the System Flow Graphical User Interface. The System Flow Graphical User Interface is a standard GUI that is built using the functions within the System Flow API function library. It forms a complete, ready-to-use, real-time recording and playback instrument. It has easy-to-use and intuitive screen buttons, checkboxes, text fields, and drop-down lists. It configures and initializes all of the real-time hardware within the recording system, and it also controls and monitors all the real-time hardware operations within the recording system as well. The GUI allows a user to record data from an onboard A to D converter within the recording system to a file. In addition, the GUI also allows a user to play back data from a file through an onboard D to A converter if the recording system is optionally equipped with a D to A converter. The System Flow GUI also comes with both an integrated signal viewer and an integrated file viewer. The signal viewer allows a user to preview a live input signal both before a recording session is initiated and while a recording session is in progress. The file viewer allows a user to view a previously recorded file after a recording session has been completed and while a playback session is in progress. Now let's take a quick look at the System Flow GUI screens. First up is the System Flow GUI configure screen, which is the first screen that the System Flow GUI presents after being launched. At the very top left of the screen, you see 5 screen tabs, which are used to select the 5 main System Flow GUI screens, which are the configure, record, play, status, and about screens. The configure screen allows the user to configure various system components and operating parameters associated with the operation of the recording system. In addition, it also allows the user to set up the recording system to operate as either a local server or a remote server. The upper left section of the configure screen has the profile configuration buttons. A profile represents a complete Talon recording system configuration for all I/O interface boards contained within a specific server and includes parameters for the ADCs, DACs, DDCs, DUCs, as well as other recording and playback settings. The Load Profile button is used to load an existing profile that was previously saved, while the Save Profile button is used to save the current configuration settings to a new profile. So as you can see, the profile configuration buttons are a very convenient tool for a Talon Recording System user because it provides them with both a set up once and save capability and a reproduce as many different scenarios as you want capability. The upper middle section of the configure screen has the remote server configuration panel. This is where you can enter the server name and the IP address of each Talon Recording System server that the SystemFlow GUI client needs to connect to and control remotely. The lower right section of the configure screen shows a block diagram of a Talon Recording System that is being used and controlled by the SystemFlow GUI. The lower left section of the screen has the server configuration panel. The server configuration panel allows a user to access individual configuration screens, which you shall see in just a moment, that are used to configure specific resources associated with an I/O interface board contained within a Talon Recording System server. I/O interface board resources such as the A to D channels, the D to A channels, and the clock source can all be individually configured. Also, the server configuration panel provides the user with the ability to individually configure the resources associated with multiple I/O interface boards within multiple Talon Recording System servers. This is the clock parameters configuration screen. This screen allows the user to set the clock parameters associated with an I/O interface board within the recording system. The sample clock source, the sample clock frequency, the A to D sample clock rate, the D to A sample clock rate, and a reference clock frequency can all be specified or set via the clock parameters screen. This is the ADC-DDC parameters configuration screen. This screen allows the user to set the ADC or DDC parameters associated with one of the A to D channels on an I/O interface board within the recording system. The signal bandwidth, the decimation factor, the center frequency, digital down conversion mode, and gate or trigger mode can all be specified, set, or enabled via the ADC-DDC parameter screen. In addition, both the calculated input sampling rate and the calculated disk data rate corresponding to the A to D input channel are displayed on this screen as well. This is the DAC-DUC parameters configuration screen. This screen allows the user to set the DAC or DUC parameters associated with one of the D to A channels on an I/O interface board within the recording system. The signal bandwidth, the interpolation value, the center frequency, digital up conversion mode, and gate or trigger mode can all be specified, set, or enabled via the DAC-DUC parameter screen. In addition, both the calculated output sampling rate and the calculated disk data rate corresponding to the D to A output channel are displayed on this screen as well. When you click on the Record SystemFlow GUI Screen tab, the SystemFlow GUI Record screen shown on this slide appears. The Record screen allows the user to configure various settings and attributes associated with a recording session. In addition, it also provides the user with the ability to directly control a recording session as well. The Record screen is divided into two sections, the Record Channel Control section, which is the lower section of the screen, and the Record Master Control section, which is the upper section of the screen. The Record Channel Control section, which is the lower section of the screen, allows the user to enter a file name for each input channel to be recorded, as well as set the recording transfer length, manually start and stop the recording, and monitor the status of the recording for each input channel to be recorded. Now, a recording session for any input channel that has been selected to be part of a simultaneous multi-channel recording via having their corresponding master record checkbox being selected within the Record Channel Control section of the record screen would not be controlled by the Record Channel Control section of the screen. The Record Master Control section of the screen would be used instead. The Record Master Control section, which is the upper section of the screen, allows a user to control a simultaneous multi-channel recording. It is also the place within the SystemFlow GUI where the user would go to access the integrated signal viewer. This is the SystemFlow GUI Signal Viewer screen. The Signal Viewer allows a user to monitor live input signals both before and during a recording in both the time and frequency domains. As you can see, the upper portion of the Signal Viewer screen presents two display windows, the time window on the left and the frequency magnitude window on the right. In addition, the bottom portion of the Signal Viewer screen provides the user with a wealth of signal analysis tools, including amplitude and frequency calculators, distortion calculators, averaging modes, zooming and panning controls, and cursors for exploring spectral components within the frequency domain. Keep in mind that all of these signal analysis tools are available to the user right out of the box without the user having to write any code whatsoever. When you click on the Play System Flow GUI screen tab, the System Flow GUI Play screen shown on this slide appears. The Play screen allows the user to configure various settings and attributes associated with a playback session. In addition, it also provides the user with the ability to directly control a playback session as well. Just like the Record screen, the Play screen is divided into two sections: the Play Channel Control section, which is the lower section of the screen, and the Play Master Control section, which is the upper section of the screen. The Play Channel Control section, which is the lower section of the screen, allows a user to enter a file name for each output channel to be played back, as well as set the playback transfer length, manually start and stop the playback session, and monitor the status of the playback session for each output channel to be played back. In addition, if the loop checkbox is selected for any output channel, then the file associated with that output channel will be played back repeatedly, looping back to the start position after the requested transfer time or length. A playback session for any output channel that has been selected to be part of a simultaneous multi-channel recording via having their corresponding master play checkbox being selected within the Play Channel Control section of the Play screen would not be controlled by the Play Channel Control section of the screen. The Play Master Control section of the screen would be used instead. The Play Master Control section, which is the upper section of the screen, allows a user to control a simultaneous multi-channel playback session. It is also the place within the System Flow GUI where the user would go to access the integrated file viewer. This is the System Flow GUI file viewer screen. The file viewer allows a user to analyze previously recorded signals that are stored in files on a Talon Recording System RAID storage array. The signals within these files can be analyzed with the file viewer either after the recording session during which they were recorded has been completed, or while they are actively being played back or reproduced through a D-to-A converter on the recording system. As you can see, the file viewer is nearly identical to the signal viewer that we covered earlier and includes the same wealth of signal analysis tools. However, there are a few slight differences between the file viewer and the signal viewer, and those differences can be seen on the bottom portion of the file viewer screen. In addition, the file viewer also includes a data extraction utility, which allows a user to extract sections of interest from an existing recording file and copy that data to a new file. In addition to the extracted data that the user specified, the new file will also include the same header information that was contained within the original recorded file. And just to reiterate once again, all of these tools are available to the user right out of the box without the user having to write any code whatsoever. When you click on the Status System Flow GUI screen tab, the System Flow GUI status screen shown on this slide appears. The status screen provides the user with a log of all the System Flow GUI client transactions that occurred since the System Flow GUI client was launched. When you click on the About System Flow GUI screen tab, the System Flow GUI About screen shown on this slide appears. The About screen provides the user with both the Talon Recording System software revision number and the Talon Recording System model number. In addition, links to Pentex Talon Recording System's main website and Pentex Talon Recording System support website are also provided on the About screen as well. Additional information about Pentex System Flow software can be found in either the Talon High-Speed Recording Systems product segment catalog or the Talon RTS 2706 Recording System Operating Manual. Both are available via the Recording System section of Pentex website. In addition, you can contact Pentex directly via phone, email, or the Pentex website, and we will be happy to help you find any additional information that you need. Well, that's all the material that we had to cover for today. We'd like to thank you for taking the time to view the webcast, and we hope that you found it to be both informative and useful. Have a great day.